All right, so welcome back. We're going to be talking about LPA, latent profile analysis. It's a statistical modeling technique that estimates distinct profiles of variables. It focuses on identifying these latent subpopulations within a population based on certain sets of variables. It basically assumes that people can be typed or based on, like, they can be typed into categories. Those are the subpopulations based on different profiles or attributes. And this is pretty cool for psychology because it allows us to make these profiles based on these latent variables, these things that we study that we can't see, and it helps us to put people into those profiles based on their attributes. So we're gonna get started. I use the package Tidy LPA. It's already installed, so I am just going to bring in that package plus some others. I'm also going to import the same data set I used last time, and I'm gonna do it the exact same way. Gonna pull it in, import, and then I'm gonna rename it. And we're gonna look at it again. It's a huge data set. I tried running this with all of them once again, and it took a really long time, and it was too messy, I guess. So what I decided to do was take a random sample of this larger sample and just go from there. I took a sample of 50. So I'm going to use set seed because since I've been doing this a few times and I want to get the same results every time, this makes sure that my random assignments are always the same. So I'm going to run that. And then I'm going to assign this as my sample. It's going to take 50 random rows. And then I'm going to name it df, and it's going to subset those 50 rows. And then here we go. I've got only 50 cases now, which is going to be a lot easier to deal with. So first, getting into this LPA, we're going to take a summary. I'm going to call it M3 because I'm going to look at 3 classes. These are the 3. Oh, by the way, I use this in the last in the cluster analysis too, but this pipe symbol just basically passes the results of one function to the next, and it comes from this library, I believe. So that's my data. These are the continuous variables that I'm using, which, by the way, is why I'm doing an LPA, not an LCA, where those are like binary variables instead of continuous. I'm going to do a single implementation. I'm also going to scale it and then estimate the profiles, which I'm going to do model 1 and the 3 classes. To be honest, I'm basically doing this because it is the most popular way of doing things, and I am not quite comfortable enough with the theory to go into the other models. But yeah, from what I understand, this is the most popular model, and I'm going to look at 3 classes. So yeah, I'm going to check that, and then I'm going to run it. And it's showing me here, so they're all model 1s, and then I have class 1, 2, and 3. For now, I'm going to stick with AIC, BIC, and entropy because I'm most familiar with those. AIC and BIC are the most common used fit index, and the smallest values are the best representation. I'm going to use them both because I am aware that you're not supposed to just choose one of these fit indexes, so I'm going to use them both. And it turns out that My lowest values are in class 3, and I have entropy, which is certainty, meaning it's 94% certain, so I will take it. And then I'm going to plot the profile. And so this is plotting the model, all three, the classes, all three classes among three classes. Yeah, I'm a little confused by this. This is not what I want to look at. So I'm gonna, since I'm only gonna use this third class because it seems to be the best fit, I'm gonna run this again, but with just this third class here, and then hit there. As you can see, this is that same line from right here, and then I'm just gonna plot this again, and this makes a lot more sense to me at least. So yeah, these are the profiles that I've got. You can see for class 1, we've got higher in age, lower in length of service at the organization, and highest amount of hours absent from work. In the second class, we've got the lowest age, the middle amount of length of service, and the least amount of absent hours. And then we've got the third class, which is the middle age section, the highest amount of length of service, and the middle amount of hours absent. So if an organization were to use this data, they might use these profiles to recognize certain types in their organization. For example, and maybe this isn't probable, but if they were looking to promote based on least amount of absent hours, it might help to see like what other attributes that group has. I don't know if this is making sense, but so say this second group has the least amount of hours absent. They have the middle amount of service and they're the youngest of the sample. They might see that that group of younger employees who have been there for an average amount of time are the ones showing up, and they can use that profile for subsequent analysis and vice versa for those that are missing a lot. Forget the thing I said about promotion. I don't think that really helps, but it will help for subsequent research. And when doing that subsequent research, you're going to want the data that kind of built this, so you can print that by using get data, and then it's going to have those scaled scores for every single case, so all 50, which is nice to have if you want to conduct more research based on these profiles. And then in the get fit, this is going to show extra fit indexes, which I don't know that much about, but if you want to do more stuff, it can help you, and you can see more of the data if you are really onto something. And then I have get estimates, which is going to show the means and standard error of all the data. So you can see we've got the mean for each variable in class 1, model 1, classes 3, and then it'll give you the means and variances for the same variables in class 2, model 1, classes 3, and then same for class 3. So this is also some helpful data if you want to keep going. So this is what I have for LPA. Pretty interesting, and it definitely gives you a little bit more information on these profiles than you get from clustering. So I think I am beginning to see the difference between the two, and I'm looking forward to talking about this in class on Wednesday. See you later.